Hi everyone, welcome to Rich Brain. In today's video, we are going to solve Valley View University End of Semester Examination 2021-2022 academic year on partial differential equation. So in this examination, it is divided into two sections, section A and section B. Students are supposed to answer 4 questions in section A for 20 marks. And one question in section B, which is compulsory, for another 10 marks. In this video, we are going to find solution to all the questions in section A. This will be a very interesting engagement, so please come along. So the question 1, which is worth 5 marks, says that use the Lagrange method to find solution to the partial differential equation by 4 the partial differentiation of u with respect to x plus 6 the partial differentiation of u with respect to y, all equal to 10 bracket k plus y, and this is worth 5 marks. So this particular question is on using the Lagrange method or the method of characteristics to find solutions to first order partial differential equations. And when we are asked to use the Lagrange method to find solution to first order partial differential equations, the solution to the equation is given as f of pi, phi equal to 0. What is this pi and this phi? This pi and phi are the constants we get from solving the characteristics equation. How do we form the characteristics equation? The characteristics equation is dx over the coefficient of the partial differentiation of the function with respect to x, so 4, and it will be equal to dy over the coefficient of the partial differentiation of u with respect to y, so that will be 6, equal to du, that's the dependent variable, over what is equal to, so 10 all over k plus y. So how do we find this? We take this equate to this, take this equate to this to get the two constants. And those two constants, the first constant is the pi and the second is the phi. So we are trying to find the first constant, which will be pi. So we equate the first two to each other. So dx over 4 equal to dy over 6. So we cross multiply. We get 6 dx is equal to 4 dy. What do? We integrate both sides. So we have 6 integral dx is equal to 4 integral dy. Now we integrate this, we'll get x. So that will be 6x equal to 4y, then plus our constant c1. So our 6x minus 4y is equal to c1, and this will be equal to our pi. So we can identify that the pi is equal to 6x minus 4y. Now the next is to find the second constant, phi, and that we equate this to that. So our next step is to find the constant phi, and that will be getting by equating dy over 6 equal to du over 10 bracket k plus y. Then we'll cross multiply again. We get 10 k bracket 10 bracket k plus y dy equal to 6 du. We can expand this, so we'll get 10k plus 10y dy is equal to 6 du. What do? We integrate both sides, so we find integral of 10k plus 10y dy equal to 6 integral du. Now how do we integrate? Remember k is constant, so to integrate this, we integrate it 10 by 10, so we get 10 ky plus the integral of this, remember the integration rule. So if we have 10y, remember integration rule says this is exponent 1, so we add 1 and divide the result, and divide it by the result. So we have 10 divided by 2 will be 5, so we'll get 5y squared. So that will be 5y squared equal to the integral of this will just be u, so that will be 6u, then plus our constant c2. So we have 10ky plus 5y squared minus 6u will equal to c2. So we can repolish this. You see 5y is common, so we can bring 5y out. Y is common, so we'll have 2k then plus y minus 6u equal to c2. So we can say this is equal to our phi. So the phi will equal to 5y bracket 2k plus y minus 6u. So, having identified pi to be 6x minus 4y and our phi to be equal to 5y bracket 2k plus y minus 6u, we can say that the solution to this first order partial differential equation using the method of Lagrange will be f into bracket pi, which is 6x minus 4y, comma, the phi, which is 5y bracket 2k plus y minus 6u, all equal to 0. I hope you get that. So the second question says that we should show that cos into bracket 3x minus y is a solution to the partial differential equation defined by del square u over del x square equal to 9 del square u over del y square, and this is worth 5 marks. So please remember to subscribe to my YouTube channel, share my videos and comment. It is the only way you can help promote my YouTube channel so that I can share more mathematical content with you. So this particular question is on how to determine if a function is a solution to the partial differential equation. Please, if you want a video on this, check that video in my description box. It will help. So how do we do that? We will differentiate the function into the order of the partial differential equation. Then after that, we substitute into the partial differential equation. If the left-hand side is equal to the right-hand side, then we said that the function is actually a solution to the partial differential equation. If it is not, then we conclude it is not a solution to the partial differential equation. So this is the function. So we said we should let u of xy to be equal to cos 3x minus y. Now we need to find our del u over del x. That means we'll differentiate this function with respect to x. Remember, when we are performing partial differentiation of a function with respect to x, the other function or functions are head constant. So in this case, our y will be head constant. So to differentiate this, remember we differentiate this and use it to multiply the differential, of course. Do well to check out my videos on how to differentiate trigonometric functions on YouTube. So when we differentiate this, we'll get 3. So we'll have 3. The differential, of course, will be negative sign. Then we repeat the angle, 3x minus y. So this will be del u over del x will be equal to negative 3 sine 3x minus y. Now we find the second derivative since our partial differentiation is to order 2. So we find del square u over del x square, and this will be equal to, we differentiate again. When we differentiate this, we get 3. We need to multiply this, it will be negative 9. Then the differential of sine is cos. Then we repeat the angle 3x minus y. So our next step is to find the partial differentiation of the function with respect to y twice. So first, we need to find the partial differentiation of this function with respect to y first. So here the x will be held constant. So this is constant. When differentiate to be 0. When we differentiate negative y, we'll get negative 1. It is negative sine Then we repeat the angle 3x minus y. So we can say our del u over del y is equal to the negative 1 times this will be positive. So we'll get sine 3x minus y. Now we'll find a partial differentiation again with respect to y. So we'll differentiate this since we need the second derivative. We'll get del square u over del y square will be equal to, now we differentiate this again. When we differentiate this, we'll get negative 1 again. The differential of sine is cos. Then we'll repeat the angle 3x minus y. So we can say our del square u over del y square is equal to negative cos 3x minus y. So having know our del square u over del y square and del square u over del x square, we substitute into the partial differential equation to see if the right hand side will be equal to the left hand side. So now we substitute. Having know our del square u over del x square to be negative 9 cos into bracket 3x minus y, and del square u over del y square is equal to negative cos into bracket 3x minus y, we substitute into our partial differential equation. So our del square u over del x square is negative 9 cos into bracket 3x minus y equal to 9. Our del square over del y square is negative cos 3x minus y. So this will be negative 9 cos 3x minus y, and it is equal to negative 9. That's 9 times this will be negative 9 cos 3x minus y. So you can see that our left hand side is equal to our right hand side. So since the left hand side is equal to the right hand side, we can conclude that cos into bracket 3x minus y is a solution to our partial differential equation, which is del square u over del x square equal to 9 del square u over del y square. I hope you get that. Our next stop is the question number 3. So our question 3 says that we should classify with reasons the partial differential equation defined by 5 del square z over del x square plus 6 del square z over del y square equal to xy as elliptic, parabolic, or hyperbolic. So this particular question is on how to classify second order partial differential equations as being elliptic, parabolic, or hyperbolic. Please do well to check out my videos on classification of second order partial differential equations, or get a link to that video in my description box. So in that video, we said that to classify a partial differential equation as being parabolic, elliptic, or hyperbolic, we use the discriminant, that's b squared minus 4ac. What is this b and what is 4ac? What is our ac? So we said that when b squared minus 4ac is equal to 0, then our second order partial differential equation will be considered as parabolic. Then if it is less than 0, it will be elliptic. When it is greater than 0, it will be considered as hyperbolic. And what is this b and what is a and c? We said that our a is the coefficient of the partial differentiation of the function. So in this case z with respect to x twice, and our b is the partial differentiation of the function with respect to z, the partial differentiation of the function z with respect to x, then with respect to y, and the c is the coefficient of the partial differentiation of the function z with respect to y twice. So we just locate the coefficient from our partial differential equations, then we substitute to see the end result. So in this case, all compared, we can say that our a is equal to 5. Then the partial differentiation of the function with respect to x, then with respect to y, is not there. So we'll consider the coefficient to be 0. So we say b is 0. Then our c in this case will be 6. I hope you get that. So we substitute. You can say 0 square minus 4 times 5 then times 6. 0 square is 0 minus 4 times 5 is 20. 20 times 6, that will be 120. 0 minus 120 will be negative 120. And negative 120 is less than 0. So since it is less than 0, classifying with reason, we can say that since b squared minus 4ac is less than 0, our partial differential equation is elliptic. So we say since our b squared minus 4ac is less than 0, then the partial differential equation, which is 6 del square z over del x square plus 6 that's 5 del square z over del x square plus 6 del square z over del y square equal to xy is elliptic. I hope you get that. Our next stop is a question number 4. So our fourth question says we should find a particular solution to the partial differential equation defined by del u over del x plus 3 del u over del y equal to 0 with a boundary condition u into bracket 0 comma y. It should be y because of the horizontal. So it's 0 comma y equal to 4 sine y. So how do we go about it? So this particular question is on finding solution to first order partial differential equations. And when it comes to that, there are a lot of methods we can use. However, the method I will use in this video will be the geometric method in solving this particular question. Please do well to check out my videos on how to solve first order partial differential equations using the geometric method on YouTube, or get a link to that video in my description box. So to find solution to first order partial differential equations using the geometric method, we said the general solution to the equation, that's u x comma y, is given by a function of bx minus ay. What is this our b and what is the a? The b is the coefficient of the partial differentiation of the function with respect to y. And the a is the coefficient of the partial differentiation of the function with respect to x. So we can say our b is 3 and our a is 1. Then we can say the general solution to the partial differential equation using the geometric method will be equal to a function of 3x minus a is 1. So we say 1 times y will still be y. I hope you get that. So now, since some boundary conditions are given, we substitute the boundary condition into it to get a particular solution. And the boundary condition is x of 0, y is equal to 4 sine y. So that means we substitute 0 in the place of x, so x of u of 0, comma y will be equal to f of, you can say 3 times 0 minus y, and it will be equal to 4 sine y. We can say u of 0 comma y equal to f of negative y all equal to 4 sine y. So since f of negative y is equal to 4 sine y, we need to get a proper solution to this. So we say we let a to be equal to our negative y. So we can say our y will be equal to negative a. So any place we see negative y, we substitute a. And any place we see y, we substitute negative a. So we can say our f of a, negative y is a, so f of a will be equal to 4 sine y is negative a. So our f of a will be equal to C. In trig, if you have sine negative a, it is the same as negative sine a. So we can say this is negative 4 sine a. So since our f of a is equal to negative 4 sine a, then our f of 3x minus y will be, so our f of 3x minus y will be equal to negative 4 sine 3x minus y. Then we can say the general solution or a particular solution to our partial differential equation using the geometric method will be u of xy equal to negative 4 sine 3x minus y. I hope you get that. This is a very simple method. When you use the geometric method, it is very simple. We'll go to our question number 5. So our question number 5 says that we should find the partial differentiation of the function with respect to the function f with respect to x, that's I, then I. Find the partial differentiation of the function f with respect to y if the function f dependent on xy is given as e exponent s squared y squared the square root of s squared plus 1. So this particular video, or this particular question, is on how to perform partial differentiation. Please do well to check out my video on how to perform partial differentiation on YouTube, or get a link to that video in my description box. So what we must know is that anytime we have a function depend on two variables, maybe x and y, performing partial differentiation of the function with respect to one variable, then the other variable will be held constant. So that's what you must be rest assured. So we want to differentiate this function with respect to x, then the y will be held constant. So if y is held constant, look at this is a function multiplying another x function, even if the y is constant. Then we must use product rule to differentiate that function. So how do we do that? So we just let our u to be equal to e exponent x squared. Then we let our v to be equal to y squared, the square root of s squared plus 1, which can be rewritten as y squared s squared plus 1 exponent half. I hope you know that. Then we'll perform the partial differentiation of the function u with respect to x. So we have our del u over del x. Please remember how to differentiate the exponential function. We differentiate the exponent and use it to multiply the function. So one differentiate x squared, get 2x e exponent x squared. Now we perform the partial differentiation of this function v with respect to x again. So the y will be held constant. So now we'll just differentiate this and hold the y constant. So this will be differentiated using chain rule. So we'll drop this, we differentiate what is in the bracket, repeat the bracket, and subtract 1 from the exponent. So when we drop half, so we drop half to multiply the y squared, we differentiate x squared plus 1, we get 2x. We repeat the bracket, which is x squared plus 1, and subtract 1 from the exponent 1, a half, we get negative half. So we can repolish this. Our del v over del x will be equal to, see, these two can divide that 2. So we have x, so we have xy squared there. Then our x squared plus 1 exponent negative half. This can be rewritten as del v over del x is equal to xy squared all over x squared plus 1 or exponent half using indices. And remember, our del u over del x is equal to 2x e exponent x squared. So from product rule is saying that, so our partial differentiation of the function with respect to x will be equal to v del u over del x plus u del v over del x. So now we substitute. So we can say that our partial differentiation of the function with respect to x will be equal to v. And our v, remember, is this. Is y squared, the square root of x squared plus 1. Then times our del u over del x. And del u over del x is this. Is 2x e exponent x squared. Plus our u, which is e exponent x squared. We have e exponent x squared. Then our del v over del x is xy squared all over x squared plus 1 exponent half. So we can simplify this further and say the partial differentiation of the function with respect to x will be equal to 2xy squared e exponent x squared. Then this, the square root of x squared plus 1, can be written as x squared plus 1 exponent half plus x y squared e exponent x squared all over x squared plus 1 exponent half. So what do? We can find the LCM and simplify this further. So the LCM of this is x squared plus 1 exponent half. So if this, remember this is over 1, the denominator is over 1. When you divide that, it will still be this. Multiply by this, we'll get 2x y squared e exponent x squared plus 1 exponent half times x squared plus 1 exponent half. Then plus this will divide that is 1, so we'll still get x y squared e exponent x squared. On polish further, we get 2xy squared e exponent x squared. Then half, you remember when indices, the bases are the same, we just add the exponent. So half plus half is 1. So we'll get x squared plus 1, then plus x y squared e exponent x squared all over x squared plus 1 exponent half. We can expand this. So when this multiply this, we'll get 2x cubed y squared e exponent x squared. Then plus this multiply that, we'll get 2x y squared e exponent x squared. Then plus our x y squared e exponent x squared over x squared plus 1 exponent half. So I'll polish this further. Then we can say the partial differentiation of the function f with respect to x will be equal to 2x cubed y squared e exponent x squared. Then these are like terms. So 2xy squared e exponent x squared plus xy squared e exponent x squared will be 3x y squared e exponent x squared. I hope you get that. Then all over x squared plus 1 exponent half. So we can conclude that the partial differentiation of the function with respect to x will be equal to 2x cubed y squared e exponent x squared plus 3xy squared e exponent x squared all over the square root of x squared plus 1. Remember, x squared plus 1 exponent half is the same as the square root of x squared plus 1. I hope you get that. So since we know our partial differentiation of the function with respect to x, we can now find our partial differentiation of the function with respect to y. So remember, anytime we are performing partial differentiation of this function with respect to y, the x will be held constant. So this is constant. This is also constant. The only thing we'll differentiate is the y squared. So we can say the partial differentiation of the function f with respect to y will just be equal to When we differentiate y squared, we get 2y. So we get 2y e exponent x squared, the square root of x squared plus 1. That is all. It's only the partial differentiation of the function with respect to x. That is a little bit tedious. But with this, that's all. Now we'll go to the question number 6. So our question number 6 says that we should let z to be equal to a function of x depending on x and y equal to negative x squared minus half y squared plus xy plus 10. And we should find I, the partial differentiation of the function with respect to x, centered at 2, 1, and the partial differentiation of the function with respect to y, centered at 2, 1. So, the I said we should find the partial differentiation of the function with respect to x, centered at 2, 1. So again, when you are performing the partial differentiation of this function with respect to x, the y will be held constant. So we can say our partial differentiation of this function with respect to x, depending on xy, will be equal to, so this will give us negative 2x. Then since this is constant, the whole of that will be 0. Then when we differentiate this with respect to x to be y, then another constant, the differential will be 0. So we can say the partial differentiation of this function with respect to x is just negative 2x plus y. So centered at 2, 1, it means x is 2 and y is 1. So this will be equal to negative 2 times 2 plus 1, and this will be negative 4 plus 1, and that will give us negative 3. Our next step is to find the partial differentiation of the function with respect to y centered at 2, 1. So when we are going to find the partial differentiation of the function with respect to y, the x will be held constant. So we can say the partial differentiation of the function with respect to y centered at xy will be equal to, since this is constant, the differential will be 0. Then when we differentiate this, we get negative 2, remember half y, that means we'll drop this and subtract 1. Then plus, when we differentiate it with respect to y, it will be x. Then this is constant, it will be 0. When we polish this further, negative 2 times half will be 1. So we'll get negative y plus x. Then we can say the partial differentiation of the function with respect to y centered at 2, 1. That means y is 2, x is 2 and y is 1. Then we say negative 1 plus 2. And this will be negative 1 plus 2 is 1. I hope you get that. So we'll end it here today. Please remember to subscribe to my YouTube channel, share my videos, and comment. Your comment keeps me going. These are the only way you can help promote my YouTube channel so that I can share more mathematical content with you. Until we meet again, my YouTube channel is Rich Brain and my name is Strategic Kepsi Richard.